Hello everyone. Welcome to the Construction Technology course. Lu Xun once said, "A great building is always built piece by piece, wood by stone. Why not let us be those very pieces?" I often do small, seemingly trivial things, and that is exactly the point. Construction is like this, so is being a person, and so is learning. I hope you will value the cultivation of good daily habits, and the accumulation of knowledge bit by bit. Small streams added together become rivers. Paces accumulated reach 1,000 miles. Step by step, you will finally build your own towering edifice. Today, we begin Chapter 5. Reinforced Concrete Works Construction. Let's start with formwork engineering. Through this module, you will understand the requirements and classifications of formwork, be able to organize and manage formwork construction, and master the specifications for formwork installation and removal. As we all know, an advantage of concrete components is their excellent workability. This property is made possible through the use of formwork. Formwork is the mold used to shape freshly poured concrete. It must ensure the accurate shape and dimensions of the structure and its components, possess sufficient bearing capacity, stiffness, and stability, and reliably withstand the weight, lateral pressure, and construction loads during casting. It should be easy to assemble and dismantle, capable of multiple reuse cycles, and have tight joints to prevent grout leakage. First, let's look at the basic components of formwork. From the perspective of materials, formwork can be classified into timber formwork, steel formwork, plastic formwork, and others. From the perspective of construction methods, it can be divided into cast-in-place concrete formwork, preassembled formwork, and others. Among these, timber formwork and steel formwork are the most widely used. Timber formwork appeared at the very beginning of concrete construction and remains in use today. Timber is first processed into planks or battens, then assembled into the formwork needed for the structure. Its advantages are low cost and cost-effectiveness. Disadvantages include high material loss and limited reusability. Steel formwork is made from steel and available in different sizes. Small panel steel formwork consists of individual panels made to specific modular sizes. Panels of varying dimensions are assembled during construction to achieve the required component dimensions, also known as modular steel formwork. Large panel steel formwork is used for wall forming, commonly applied in shear wall structures. Its size is customized according to the designed wall dimensions. Modular steel formwork primarily consists of steel panels and accessories. Steel formwork panels are divided into flat panels and corner panels. Corner panels are further divided into internal corner panels and external corner panels. Accessories for fixing mainly include U-clamps, L-pins, through-tie bolts, and other fittings, besides the formwork panels themselves. Another crucial component is the adjustable steel prop. Modern construction mainly uses adjustable steel props, consisting of an outer tube and an inner tube. Their height can be adjusted. Steel tube scaffolding is composed of steel tubes and couplers. Vertical standards can be lengthened by butt jointing or lap jointing steel tubes. Next, let's understand the fabrication and installation of formwork for different structural components. This illustration shows the formwork construction for a cast-in-place concrete foundation. It is assembled from 4 side panels, 2 of which match the dimensions of the corresponding step sides. The other 2 are 150 to 200 millimeters longer than the corresponding step sides. All panels are of equal heights. During installation, it is essential to ensure no displacement between upper and lower panels. Column formwork consists of 2 inner form panels placed between 2 outer form panels. A cleaning opening is provided at the bottom of the column formwork, and pouring openings are set every 2 meters along the height to resist lateral concrete pressure. Column ties are placed externally around the panels. Column ties can be made of timber, steel, or steel timber composite. The spacing of column ties depends on the magnitude of concrete lateral pressure and the panel thickness. Since lateral pressure is greater at the bottom and decreases upwards, column ties are spaced closer together at the bottom. The top of the column formwork has notches for connecting to the beam formwork as required. Beams often have large spans but are not particularly wide. The beam soffit is usually suspended. Concrete exerts horizontal lateral pressure on the beam side formwork and vertical pressure on the soffit. Therefore, the beam formwork and its support must withstand these loads without excessive deformation beyond permissible limits. Beam formwork mainly consists of soffit panels, side shutters, timber wailers, and a supporting system of props. The soffit panel, which bears vertical loads, is generally thicker and supported underneath by props. The side panels bear lateral concrete pressure and are fixed outside the soffit panel. The soffit panel is fixed with cleats, while the top is secured with inclined struts and horizontal ties. If the beam span is 4 meters or greater, the soffit panel should be cambered upward, if not specified in the design. The camber height should be 1/1000th to 3/1000ths of the span length. Next, we will learn about formwork removal. Formwork removal primarily depends on the concrete strength. For cast-in-place structures, the removal of formwork and support must comply with strength requirements. If no specific design requirements are provided, the following conditions must be satisfied. Side formwork can be removed only when the concrete strength is sufficient to ensure that its surfaces and edges are not damaged by removal. The soffit panel may be removed only when the concrete strength meets the standard requirements. Removal sequence is critical. Generally, follow the principles of last installed, first removed. Remove non-load-bearing components before load-bearing ones, and proceed from top to bottom. For major or complex formwork, a dismantling plan shall be prepared in advance. Safety requirements during formwork removal. 1. During dismantling, operators shall stand in safe positions to prevent accidents. 2. Avoid using excessive or sudden force during removal. The use of sledgehammers or crowbars for forceful removal is strictly prohibited to prevent damage to concrete surface or formwork panels. 3. Do not throw removed formwork panels and accessories. They should be handed down, stacked in designated areas, and promptly cleaned, repaired, and coated with release agents for reuse. During the formwork dismantling, if defects in the concrete that may affect structural safety are found, the dismantling shall be suspended until proper remedial measures are taken. Finally, let's look at the design requirements for formwork. The content of formwork design mainly includes form selection, material selection, accessory configuration, load calculation, structural design, and construction drawing preparation. The content and level of detail of each design may be determined according to the specific project conditions and construction requirements. Formwork design requirements include: first, formwork and its support system must be designed considering the structure form, load magnitude, type of foundation soil, construction equipment, material supply, and other relevant conditions. The formwork and its support system must have sufficient strength, stiffness, and stability. The bearing components of the support system must provide adequate bearing area to safely withstand the weight of poured concrete, lateral pressure, and construction loads. Second, based on the design drawings, a construction plan shall be prepared, and the formwork shall be designed accordingly. The formwork and support system must be verified for the loads determined by the construction conditions, and testing shall be carried out where necessary. Before concrete pouring, the formwork installation must be inspected. Third, during formwork installation and concrete pouring, the formwork and its supports must be monitored and maintained. If any abnormal conditions occur, implement measures promptly according to the construction plan. Fourth, materials used for formwork engineering must be carefully selected and inspected. Materials that do not meet quality requirements shall not be used. Formwork construction should aim for simple fabrication, ease of operation, durability, and ease of transportation and repair. Finally, let's summarize what we learned in this lesson. We have covered the performance requirements of formwork, formwork classification and components, installation of formwork for key components such as foundations, columns, and beams, formwork dismantling requirements, and formwork design requirements. Please review carefully after class.